Tigers, we are going to be working with equations today. We are going to be changing equations that are in standard form to slope-intercept and slope-intercept back to standard form. Also, I can construct a linear function in standard form from a description of a relationship. We'll come back to that in just a little bit, but for now, we're just going to remind ourselves of what the form of the equation looks like when it's in standard form. Standard form is when an equation reads ax plus by is equal to c, meaning ultimately x plus y is equal to c, or the constant. On a side note, if you have changed the equation from slope-intercept to standard and your a term is negative or greater than 0, as it reads here in this text, then we are going to multiply by -1, or you can divide both sides by -1 to make sure that the a is in fact greater than 0. I'll show you how to do that. We'll have an example of that in just a little bit. And then this ever so familiar equation, I know you know it very well, y is equal to mx plus b, or slope-intercept. And if an equation is slope-intercept form, then we have to know how to change it back to standard form. Both equations are used for different reasons, and you'll learn more about that later. Change from standard form to slope-intercept form. So as you can see, we talked about the original equation in standard form would be ax plus by is equal to c, or the constant. As you can see, it's in the format standard form, and so we are going to change it into slope-intercept form. We know that any equation that's in slope-intercept form is going to be equal to y. So the idea here is to isolate y, or get it by itself. In order to do that, then I'm going to subtract 2x on both sides of the equation. So all that's left on the left is y. And I know when it's in the format y is equal to mx plus b, then my x term is up front. So I'm just going to go ahead and write negative 2x, and then remember that this is a -7, which would be my y-intercept. The second example, 5x minus 2y plus 2. It's not exactly in standard form, but it almost is. It's just that our 2 is on the left side, which eventually will be our constant. On the right side, we know that it becomes its opposite. So really on this problem, I can do 2 steps in one. I can get rid of the 5x, because here's what I'm trying to get by itself, y. So in order to do that, I'm going to subtract 5x on the left, and also I'm kind of out of space, as you can see. You can make it work. And then this positive 2 can also be moved to the other side of the equation. If you're more comfortable, you can do that in 2 steps, but really we know that eventually I want negative 2y to be by itself. So I have negative 2y, and then on the right I'm going to have negative 5x minus 2. Now to get y by itself, I need to divide through by a -2, because we know that this means -2 times y. The opposite of multiplication is division, and we always divide by the coefficient. The coefficient in this case is -2. So that's easy on the left. We know that all that's left is going to be our y term. And then on the right, we have to remember that we're dividing both terms by -2. So a negative divided by a negative is going to give me a positive. So I'm just going to say 5/2 x. And then I've got a -2 divided by a -2. That's going to give me a +1. As far as the m term being an improper fraction, that is perfectly okay. In fact, I would prefer that you leave it as 5/2 x plus 1. So what do we do in this problem? We got y by itself. This is kind of like when you guys were working with solving for a particular variable. So as you're doing these problems, I want you just to think, I'm always solving for y. How do I get y by itself? So we subtracted 5x, we subtracted 2 on the right, and then we're not solving for -2y, we're solving for y. So that's why we divided both sides by -2. Remember that a negative divided by a negative here is always a positive, and you can just leave that as an improper fraction. On example number 3, once again, we are solving for y. We want to put it in slope-intercept form. That's otherwise known as y equals, oopsie, I like the highlighter. We'll just leave it that way. Y is equal to mx plus b. Okay, making sure I have ink. So to get 3y by itself, I'm going to have to add 3x to both sides of the equation. So that makes it go away. All that's left on the left is 3y is equal to, I'm going to go ahead and move my 3x up front because I know that that's my equation, y is equal to mx plus b. Now I want to divide through by the coefficient of 3. When I do that, all that's left on the left is y. 3 divided by 3 gives me 1. I'm just going to write x. I don't need to write 1x. And then 6 divided by 3 is 2. So make sure that you have simplified. One more example, moving from standard form to slope-intercept form, we're going to get, in this case, it's a 2y. We're going to get that by itself. So I notice I have a -7x. I want to add 7x to both sides of the equation. Another way to think of that is when -7x travels over the equal sign, it becomes its opposite. We end up with 2y is equal to 7x. Again, moving my x up front and my y-intercept to the right, because we know that this is my mx term or my m, and this is going to be my b. Now I want to divide through by 2. And this is a really good example of when to leave a value in improper fraction form and then when to turn it into a mixed number. And here's my advice. When we're talking about m can be improper. When I'm graphing, which is what we're moving towards, when I'm graphing, I would rather go up 7 and over 2 than up 3.5 and over 1. So slope, leave is improper. However, if I'm graphing the y-intercept, then we're talking about either graphing 7/2 on the y-intercept or 3.5. So of course you'd rather find 3.5 than count up 7/2. So you should change that into a mixed number. Oh, there is one more on this, and all I would say on this problem is just flip-flop these since I know that I'm solving for y, and we'll just divide through by 3. So your final answer, y is equal to 4/3 x. Easiest way to get there. Now we're going to be changing from slope-intercept form to standard form. In this case, we have a y. The y is already on the left. We know that this is the equation, right? This is what we're working towards. Ax plus by is equal to c. So where in slope-intercept form we were solving for y, in standard form, really we're solving for c, or the constant. So the idea is to get the constant by itself. So I'm going to just leave, this is a +5, I don't just want to leave it there. I'm going to move the 2x to the left side of the equation. So if I do that, then I end up with -2x, this is a positive y, is equal to 5. Now remember on the first slide that I introduced standard form to you, and we said that if the a term is less than 0, another way to say that is if it's negative, then you can get rid of it by multiplying both sides by -1 or by dividing both sides by -1. It's entirely up to you. We just want to make sure that when we do that, we distribute the -1 to each term. So if I multiply by a -1, really all we've done is made its opposite, but if you like a number value to go along with that, a negative times a negative is going to give me a positive, and then I end up with -y is equal to -5. So the only time you have to multiply by a -1 is when your a term is negative or greater, or less than 0. So here's our final answer. Now it's in the standard form. We will use standard form when we're graphing x and y intercepts. Number 2, y is equal to -x times 7. So I know that I want to get the constant by itself. In order to do that, I've got to get that negative x standing alone. So to do that, I'm going to first multiply both sides by 7. On the left, I have 7y is equal to negative x. From here, I'm trying to get negative x to the left side of the equation. Remember, in this case, when we're moving to standard form, the idea is to solve for the constant. What's not really obvious about this problem is that there is a 0. And that is, we have to have some sort of constant to solve for. So really there is a positive 0. And it doesn't really matter which side of the equation you put the positive 0 on. I just put it there because I know that when I move the negative x, let's go ahead and let me show you doing that. When I add the x to both sides, then I've got my x term. That looks good. I've got a plus 7y, but then the question would remain, okay, what is on the right side of the equation? That kind of scares students sometimes, but really all that is there is a 0. And as you can see, that matches up with our standard form. So in order to solve for a constant, we had to basically add a constant. When nothing is on that side, a number value for nothing is 0. Number 3. In this case, you can see this kind of goes back to what we talked about in one of our first targets when we were clearing the equation of fractions. So in this case, we see really 3/4 x plus 18/4. Well, the most obvious way to get rid of the fraction is, of course, to multiply by the LCD. And I know you all are saying, oh, Miss McDaniel, I know the LCD. That is a 4. So that's what we're going to multiply by. Whenever we choose to multiply by an LCD, then we have to make sure we do that on both sides of the equation. We just want to be careful about that. Once we've figured that out, it makes the problem a lot easier. On the left, all I have left is 4y. And when I multiply by 4 and then turn around and divide by 4, all that's really left, that goes over here too, because I'm distributing here, so it's 3/4 times a fourth. All that's left is 3. And then on this 18/4 times 4, all then that would be left is 18. So when I multiply by the denominator, all that's left is the numerator. If you get confused on that part, just put 3ABC4 times 4 in your calculator and you can figure it out from there. As far as movement in this problem, I know that there's just a couple of different ways we can get there. I think the easiest way to do that is just to go ahead and move the 3x to the left. I'm going to go ahead and do that. So I'll subtract 3x on both sides of the equation. Nice 3. Now I'm highlighting. I don't want to highlight. I want to write in red. Okay, we'll get there. Now we go. So we've got negative 3x. And this is a positive 4y. So I have negative 3x plus 4y is equal to 18. Now we learned that it's not okay to have a negative a term. So now in the first example I showed you multiplying by -1. You can also divide through by -1. So I'm just going to show you that way here. And it does apply to both number. In other words, the denominator has to go into both of the numerators. So I've got a negative 3 divided by -1. That gives me a 3x. I've got a negative 4y is equal to negative 18. So we've got our format, ax plus by is equal to our constant c. In the last example, it is a word problem. It says the sophomore class holds a car wash to raise money. A local merchant donates all of the supplies. A wash costs $5 per car and $6.50 per van or truck. Step 1, or letter A, define a variable for the number of cars. Define a different variable for the number of vans or trucks. And then we're going to write an equation. So let's go ahead and first off, let's go ahead and use a variable to define our car, and then the van and truck, those are going to cost the same amount of money. I would like to use the letter C to represent the cost for the number of cars. And then I'm going to use V to represent the cost for my number of vans or trucks. Sound good? Because it told us to use a different variable. Now it says write an equation in standard form. So there's our hint. In standard form to relate the number of cars and vans or trucks the students, excuse the typo here, students must wash to raise $800. So what I know about the cars is the cost is going to be $5. So we're going to have 5C. So the C would represent the number of cars. So for example, if I washed one car, then that would be $5. Plus the number of vans. This time it's going to cost a little bit more to wash a van than it would a car. So we know that 5C plus 6.5V, and remember that we're trying to get to a total of $800. And that's all that you're expected to do. So we defined the variables, and then we wrote an equation in standard form. You can see that that looks like AX plus BY is equal to C. If you are more comfortable, you could have called this X, you could call this Y, and then no matter what, it's going to be equal to C. So I hope you enjoyed this lesson on learning to change equations from standard form to slope-intercept and from slope-intercept back to standard form.